Okay, how you doing? First thing we're going to talk about here very quickly is the original tangent function. I can go into the full blown out methodology of it or what it is, but there's some kind of bare basic facts you have to know about the tangent function. And the first thing is that its period is a length of pi. That period of length of pi is determined by when we took a look at the origin, we had to have some positive and negative values, or we were just kind of looking at the fact of where was it our values closely related to the origin, that if I picked it up and I stamped it and I kept stamping it, that would become a periodic function. And what we found here is that this tangent here, which is kind of like this, kind of looks like a x cubed curve, okay? Looks very similar to the cubic, okay? Is that what we have here is that from negative pi over 2 to pi over 2, that this is where this function became periodic, that if I pick this up and I stamp it here and stamp it here, that it will continue like this forever and ever and ever. And the same deal over here. And what does pi over 2 and pi over 2, what is the significance of those? Well, at those values, tangent is undefined. So, at the end of its period, we don't come back to a 0, we come to a vertical asymptote. On a graph or on your calculator, it's not going to draw it. You'll see this vertical line that goes down. What you need to understand is that vertical line is not real, so don't account for it. So in the graph, what you have here is you've got this basically cubic-looking graph sort of occurring, except it's not a cubic because basically it just continues to concur over and over and over again. So, sine, cosine, secant, and cosecant all go from 0 to 2 pi is their original period. What we need to now understand is that tangent, the original input values that we're concerned with, go from negative pi over 2 to pi over 2. Furthermore, some other critical values occur there that are nice for us. The very first one is that 0. Tangent of 0 is 0. So whatever we do, and no matter what we've done, I always want to have it so that when this simplifies, that it's taking the tangent of 0. And I always want to have it so that I'm taking the tangent of negative pi over 4 or taking the tangent of pi over 4. And the reason for that is because negative pi over 4 gives us a very nice output at negative 1. And pi over 4, that input, if you take the tangent of that, will always give us a very nice output of 1. So whatever values I plug into this function up here, whatever value for x I plug in, I always want it to simplify to negative pi over 4 or pi over 4. So, here we go. Let's talk about how it is that we get those values. Well, it's very simple. If I want this to simplify to negative pi over 2 and pi over 2, I set it up so that I make this compound inequality where it's not equivalent to it, but I solve it like it's inequality. And those are the values that when I solve for x will always give me this negative pi over 2 when plugged into here, and this pi over 2 when plugged into here. The other things I will have to go ahead and solve for, and I'll show you how to do that, is this negative pi over 4, 0, and pi over 4. But they're relatively pretty simple to do. So, here we go. First off, let's alter our new vertical asymptotes and talk about, okay, where are they going to be? Well, very simply, we just start solving this compound inequality. The very first thing that I'm going to do is subtract pi, okay? Subtract pi, subtract pi. Now solving a compound inequality, whatever you do in the middle, you must do to both outsides. So, forget that it's pi for a second, okay? Just think of pi as a variable where this is negative 1/2 pi and negative 1 pi. Well, a negative 1/2 minus 1 is negative 3/2. So this is negative 3 pi over 2, which is going to be less than, remember it's not equivalent to because it's a vertical asymptote. And then I'm going to have this 4x, which is going to be strictly less than 1/2 minus 1 is negative pi over 2. Okay, so negative 1 pi over 2. Continuing on with this, to finish this off, I don't like to divide. I always do multiplying by the reciprocal. So if I ever have a fraction with these, I always multiply by the reciprocal. The reciprocal of 4 is 1/4. So what I'm going to do is I'm going to come up here and I'm going to multiply everything by 1/4. Multiply everything by 1/4. And now what I have here for this instance is that 4 will reduce to 1 because anything multiplied by its own reciprocal is 1. And what I get is negative 3 pi over 8 is strictly less than x, which is going to be strictly less than negative pi over 8. And what's important about this is that these are my new vertical asymptotes. The only thing you need to remember that whenever I have for tangent is that whatever these values are, that's what my vertical asymptotes are. That also is still going to be my period. So up here, my period, I'm just going to record this information because I'm going to erase this. Okay. Once I find this new period of negative 3 pi over 8, which is strictly less than x, which is strictly less than negative pi over 8, I'm going to now use this information to find the rest of this. And basically I use this to get to here, and then I then use this to find all of my other information. So here we go. Let's talk about this period length. In a minute I'll erase this, but let's talk about this period length. Period length is very simple. You take the end point and you subtract the beginning point. Important thing to remember is that when you subtract a negative, it's really like you're adding. So I'm going to do this in my head because you should get in the habit of doing this as well, but forget pi for a second. Negative 1/8 minus a negative 3/8 is the same thing as really doing negative 1/8 plus 3/8. Well, a negative eighth plus 3/8 is 2/8. 2/8 reduces to 1/4. So my interval, my period length here is going to be pi over 4. So simple enough. The next thing you should always know to just check this work is that the coefficient of x in your original function is always going to divide the original period length by that amount. So if I come up here, the original period length of tangent is pi, because if you take pi over 2 minus negative pi over 2, you get a length of pi. Well, pi divided by 4 is pi over 4. So again, I'm just going through this and kind of checking my work along the way to make sure I'm right. My interval, okay? Interval is simple. The interval is literally take your period length and divide it into 4 equal parts. And now I'm using this interval because basically I'm just going to go to my next critical values. And what I want you to note here is that negative pi over 2 to pi over 4 is the length of pi over 4. So I'm taking basically a half step each time of whatever that length is. So my interval here, okay, is going to be pi over 4 multiplied by 1/4. Pi over 4 times 1/4 is going to be pi over 16. Now, pi over 16 is going to help me find my critical values, like the critical values you have over here are negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. The interval, all this is doing for me for my problem is literally telling me how far it is to get from one length to the next. So, because usually professors ask, well, what are the values you're plotting? So this way you can find them. So the interval is pi over 4 times 1/4. Remember, you always break it into 4 equal parts. And you get pi over 16. From here, this length of pi over 16, I'm just going to use it to add it to this each time. And each time I get a new number, I'm going to keep adding until I get to negative pi over 8. So essentially what I'm going to do is go negative 3 pi over 8 plus pi over 16, get a number, add it, okay? Mark it what it is, add another one, keep going. So essentially what I'm doing here is going negative 3 pi over 8. And the next value I'm going to add pi over 16. Well, through negative 3 pi over 8, just so you're aware, is negative 6 pi over 16. I hope we all understand that. It's just conversions here. So negative 6 pi over 16 plus pi over 16 is 5 pi, negative 5 pi over 16. Add another pi over 16. Well, that's 4 pi over 16. 4 pi over 16 is pi over 4, so this is negative pi over 4. Add another pi over 16, and what I hope you start to note here, okay, is that essentially what I'm doing here is I'm going 8, 16, 4, but that's because I'm changing them. But this went 6, 5, 4. Guess what the next one's going to be? You got it, negative 3 pi over 16. And then the last one I have is negative 2 pi over 16, which is negative pi over 8. So my last value here is negative pi over 8. These are the values that I'm going to use for my graph when I start to go ahead and graph it. And the important thing here is that I basically am just recording all of this information just to help me organize all this. So when I go to graph it, there's no questions. I go through, I fly through it, I'm done. The vertical shift, okay, remember the vertical shift is whatever you're adding or subtracting outside of the function. This is your multiplier, which is going to change these points, and I'll talk about that. So my -2 is a vertical shift, as I'm just going to move my whole axis down 2. So it's a -2, just keeping that in mind. And now I have everything I need. The next thing I want to talk about, it's not really an amplitude anymore. So I'm just going to say that my values are just altered 3. I'm not going to record it. I'm just going to use the graph here. So here we go. Let's go ahead and use this. I have everything I need now to graph. So here we go, graphing this nicely. So if I'm on this board here, keeping in mind that my interval is a negatives, okay, so I'm just going to alter what my graph looks like here. So this graph is going to start off over here. May have a little bit longer of a negative than I do the positive. But what I want you to note here is where I start. So I start at -pi/8, so I'm going to say that this length here, okay, -pi/8 is my endpoint. And I go all the way out to -3pi/8, so I'm going to go here, which this value is nice, -2pi/8. Okay, so I'm just going to go -pi/8, -pi/8, which is -pi/4. And then another -pi/8, which is -3pi/8. And what I'm now going to do here is I'm just going to simply draw in my vertical asymptotes, which are at pi/8. And at -3pi/8 and -pi/8. So here we go, drawing them in. I go to the halfway point, which, look at that, -pi/4 is already in there. But either way, I start off with looking at this value. So here's my zeroing value if we took a look at the original function. Okay. If I stuck -pi/4 into here, I'd get 4 times -pi/4, which is -pi, which is going to be pi. What I want you to note is that the halfway point between your two asymptotes will always be the 0 for your tangent function. And then again, because I'm breaking this into 4, this is the halfway point, just eyeball it, break it into half again, okay? And that, I'm not going to mark the values on my graph. I've basically got them labeled here if I wanted to know what they were, okay? And now I have everything I need. The very last step that I have to utilize here is going to be this shift of -2, okay? So, -2 is when I shift this whole axis basically down 2. So I then start at -2. So down 1, down 2, so I go to -2. And this is where I draw in my imaginary axis. I'm going to draw it in red. Okay, and I know that this part might be confusing, but I am going to use another dashed line. Okay, it's not a horizontal asymptote. Okay, what I want you to know is that this is just going to be my new axis that I'm going to use so that I can help center my function around it. So at -pi/4, I go down 2, and then if I plug that coordinate pair in, okay, that's what creates 0. So I continue on with this. So I continue on with this idea that I keep going. So now I just utilize the pattern that I would have. I go over halfway, and normally you'd go up 1, but in this case I'm now going up 3. The reason I'm going up is because this is still positive. If it were negative, I'd go over, then down. So go over over to this -3pi/16 and go up 3. So over and go up 1, 2, 3, and then here I am. So there's that point. Okay. The next step, very simple. Okay, so this value is at 1. I would go down 3, so I'd go over to the left to this value and then down 3. So down 1, 2, 3. So go to the left, go down 1, 2, 3, plot that point, and what you then have is just got to connect with a smooth curve, and then you have your tangent function drawn over one new period length. So here we go. And then that's what the new tangent function would look like for this particular graph, but it has all the things. It's, a little bit more of an explanation here for it. Do you have to do that every time? No. Do you have to list these critical values? No. What you should start to note is that all you literally have to do is that when you figure out what these values are, find the halfway point. When you find the halfway point, all you got to do is find the halfway point between those two, and you'll be done. I still like to go back to this period length and divide it, so I know this is pi/16, and then I just add to it. It's just something I got in the habit of doing. Do you have to do it that way? No, but I think it's a good way and it works nicely. So I hope that helps with whatever you're doing.